On behalf of Amity University, Jharkhand, I extend a very warm welcome to all our esteemed dignitaries, speakers, chief guests, authors, and attendees for the inaugural session of ICMMIT 2022. The Amity School of Engineering and Technology, ASET, and Amity Institute of Information Technology, AIIT, under Amity University, Jharkhand, Ranchi, has organized a two-day international conference on materials, machines, and information technology through online mode, that is Zoom, on 24th and 25th January 2022. More than 150 researchers, industrialists, and academicians will be sharing their research ideas in this conference. The aim of the conference is to create awareness among the scientists, academicians, research scholars, and students about the recent advancement in material science, manufacturing operations, computer science, and information technology, and their applications. All accepted and presented papers will be submitted in Elsevier Materials Today proceedings indexed in Scopus or IOP Conference Series Material Science and Engineering indexed in Web of Science for publication. The national and international keynote speakers from internationally acclaimed organizations like Microsoft USA, Seoul National University of Science and Technology, South Korea, Korean Institute of Energy Research, South Korea, Konkuk University, South Korea, Pine Tree Post Magnesium Company Limited, South Korea, Instituto Superior Técnico, Portugal, CSIR, CECRI, IITs, NITs, NIFT, and other reputed universities are going to share their research experience in this conference over the next 2 days. We are extremely honored and privileged to have Professor Dr. Mukul Narayan Deo, sir, Honorable Vice Chancellor of Vinoba Bhave University, Hazaribagh, Jharkhand, as the chief guest for the session today. I welcome everyone for the session. May I now request all our esteemed guests and participants to kindly rise for the national anthem. I request Mr. Rahul Kumar Lohra, our Senior Technical Assistant, to kindly share the audio visual. Everyone, please rise.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 जय।
Thank you, sir. Thank you, everyone. Saraswati Namastyubhyam Varade Kamarupini Vidyarambham Karyashyami Siddhir Bhavantu Me Sada Vande Tam Parameshwarim Bhagavatim Buddhi Pradam Sharadam. Let us, at the onset of the conference, seek the blessings of Devi Saraswati, the goddess of knowledge, to bestow on us the capacity of right understanding always and eradicate the darkness of ignorance with the divine light of knowledge. I request Rahul sir to kindly share the audiovisual for Saraswati Vandana and lighting the lamp of knowledge.
समझे, हम भी तो जाने, विद्या का हमको अधिकार दे माँ, हे शारदे माँ, हे शारदे माँ, अज्ञानता से हमें तार दे माँ, हे शारदे माँ, हे शारदे माँ, अज्ञानता से हमें तार दे माँ, हे शारदे माँ, हे शारदे माँ, अज्ञानता से हमें तार दे माँ.
Thank you, sir. I hope we can always have the light of learning burning amongst us. We can keep the light alive always forever. Engineering and Applied Science and JNC AUJ to kindly introduce ICMMIT 2022 and present the welcome address. Over to you, sir.
Thank you, Tanisha ma'am. Honorable Chief Guest, Professor Dr. Mukul Narandev sir, Honorable Vice Chancellor, Professor Dr. Raman Kumar Jha sir, respected Registrar, Professor Dr. Ajit Kumar Pandey sir, respected Director sir, Professor Dr. Ajit Kumar Pandey sir, respected Registrar, Mr. Prabhakar Tripathi sir, IMIT University, Jharkhand. Dear presenter, respected plenary speakers, my dear colleagues, student volunteers, and other colleagues and students from IMIT University, Jharkhand, Ranchi. A very warm good morning to all of you. I, Dr. Vishwarup Samanta, Joint Conference Co-Chair and Convener of ICMMIT 2022, along with our another two conference co-chair and convener, Dr. Jaita Chattopadhyay ma'am and Dr. Praveen Kumar Singh, I would like to extend a warm welcome to all of you to this 2 days long international conference on materials, machine, and information technology, which will be held during 24th to 25th January 2020. So as you know that the theme of this conference is how to use the advanced material, machines, and advanced information technology, basically industry 4.0, to give for sustainable development of today's world. So let me take this opportunity to share a few salient features of this conference with all the dignitaries and presenter who are present here from Pan India as well as abroad also. So we have received total 135 papers in this conference. And as you know, this conference, we are having 3 different tracks. So track 1 belongs to material science, track 2 belongs to machines, and track 3 belongs to information technology. So altogether, we got 135 papers. And as far as registration is concerned, we have received total more than 153 academicians, author and co-author have been registered to this ICMMIT 2022 from India as well as abroad also. And we are fortunate to get total 17 keynote or plenary speaker from India and abroad. And we are also happy to announce that all the selected and presented paper to this ICMMIT 2022 will be submitted in either of these 2 journals. One is Elsevier Materials Today Proceeding, which is indexed in Scopus, and another is IOP Conference Series, Material Science and Engineering, which is indexed in Web of Science. So your selected and presented paper will be published in one of these 2 journals. Okay, and this total 135 papers will be presented simultaneously among 3 virtual rooms, room 1, room 2, and room 3, according to their track. So if your paper belongs to track 1, so it will be presented in the room allotted for the track 1. If your paper belongs to track 2, it will be presented in virtual room 2. And if your paper belongs to track 3, then it will be presented in room number virtual room 3. And let me share that the reputed institute from where the academicians, research scholar, or UG or PG student or other faculty member who have participated or who have submitted their paper into this ICMMIT 2020-22, almost we got that participation from more than 88 institute, pan-India and abroad. I repeat, we got participation from more than 88 institutes from pan-India and abroad. Let me take few names, from these 88 institutes, like Tecnológico de Monterrey, Mexico, National Taipei University of Technology, Taiwan. Then we have got paper from different IITs also, like IIT Delhi, IIT Roorkee, IIT ISM Dhanbad, IIS Bangalore, BITS Pilani Hyderabad, Jadavpur University. We received paper from different NITs like NIT Durgapur, NIT JSR Jamshedpur, NIT Allahabad, NIT Bhopal. We received participation from BHU. We received participation from University of Petroleum and Engineering Technology, IIIT Kota, IIIT Design and Manufacturing Jabalpur, Annamalai University, Andhra University, Aligarh Muslim University, Delhi Technological University, Jamia Millia Islamia New Delhi, BIT Misra, KIT, and we have received from a paper from different MIT University also, like MIT UP, MIT MP, MIT Jharkhand, MIT Haryana, etc. And we are also privileged to have Professor Dr. Mukul Naran Dev sir, who is a Vice Chancellor, present Vice Chancellor of Vinoba Bhave University, Hazaribagh, Jharkhand. And once again, on behalf of this entire organizing team and my conveners, joint convener, Dr. Jaita Chattopadhyay ma'am and Dr. Praveen Kumar Singh, and co-conveners and joint co-organizing chair, Mr. Avijit Singh, and Dr. Pooja Jha ma'am. Once again, I would like to extend a warm welcome to all the dignitaries, all the presenter, all the student, all the colleagues present here to this ICMMIT 2022 to share our or to exchange our knowledge to make this ICMMIT successful. So with this hope and blessings from our honorable founder president sir, Professor Dr. Ashok K. Chauhan sir, our honorable chancellor sir, Dr. Atul K. Chauhan sir, senior VP U Ramachandran sir, our respected VP sir, Mr. Gaurav Gupta sir, with their blessings, we hope that that ICMMIT 2022 will achieve its success. With this hope, I would like to conclude and thank you all once again. Over to Tanisha ma'am.
Thank you so much, sir. Conference or events like these give us an opportunity to show everyone a beautiful campus. Had we been here together, we would have been proud to show you around. However, the pandemic has locked us into a virtual world, but we are going to take the aid of technology to present to you our wonderful campus and the life that we lead at AUJ Ranchi. I request Rahul Kumar Lohra sir to kindly share the clipping and present the virtual tour of ICMMIT University, Jharkhand.
Dana
Thank you, sir. I hope you all enjoyed that. May I now request the organizing chair, ICMMIT 2022, Mr. Prabhakar Tripathi, sir, respected registrar, AUJ, to kindly address the August gathering. Over to you, sir.
Thank you, Dr. Tanisha Kundu madam, for inviting me in this wonderful international conference on material, machine, and information technology. I, Prabhakar Tripathi, once again welcome all the dignitaries, Honorable VC Sir of Vinoba Bhave University, Professor Dr. Mukul Dev, our Honorable Vice Chancellor Sir, Professor Raman Kumar Jha Sir, respected Director Sir, and all esteemed speakers. As we understand and appreciate that higher education authorities are very keen and are expecting that higher education institutions like university, they must organize such conferences that may give the platform to the Gyata, Gyan, and Gye. Gyata, Gyan, and Gye, this is a very unique and particular triangular interface without which knowledge sharing is not possible. Where the knowledge seeker and the knowledge and knowledge giver combine them and they transfer the knowledge to each other. And I'm happy that IMIT University has been always a pioneer institution and has conducted so many international conferences. And of course, this conference, Material, Machine, and Information Technology, is going to be very beneficial to all the participants. And it's very unique analogy also that material and information technology are making machines. And this is like, again, a triangular analogy of Gyata, Gyan, and Gye. So I extend my sincere and heartiest wishes to the convener as well as the whole organizing team for such wonderful organizing of this international conference on material, machine, and information technology. My heartiest wishes to you all. Thank you.
Thank you so much, sir. May I now request the conference chair, ICMMIT 2022, Professor Dr. Ajit Kumar Pandey, sir, respected Director, AUJ, to bless us with his words of wisdom. Over to you, sir.
Thank you very much, Tanisha Kundu ma'am. I would like to start with a sloka Kavyasastra Vinodena Kalo Gachati Dhimatam Vyasnena cha Nidranam Vyasnena cha Murkhanam Nidrya Kalhenava. Thereby meaning for the international scholars, the prudent people, they spend their time in exchanging knowledge, discussing about the new things, sharing informations, and we are into the era of information technology. I'm a student of economics and management, but I see the theme from the perspective of not only science and technology, but from the perspective of management and economics as well. Management initially was talking about the organizing, coordinating, supervising man and material. Later on, we added machine into it. So organizing, coordinating, supervising man, material, and machine was known as management. And when we are now in the era of information technology, when everyone is so dependent upon the information, where the flow of information is deciding the flow of life that we are having, I would like to say it's not the management of man, material, and machine only. Rather, it is management of man, material, machine, and information technology simultaneously. Looking from the perspective of management, if I correlate this theme, first thing that comes in my mind is, of course, the labor market, which has gone a volte-face change ever since information technology has jumped into this particular field. Whether we talk about the electronic platform for the workers to work upon, whether we talk about the flexibility of time that the workers they are having to work upon, or we talk about the bringing parity in the wage and remuneration across the world, or we talk about the reduction of frictional unemployment, information technology cannot be understated or underestimated. During the period of pandemic, we have seen how nicely the entire labor force has shifted from the real world to the virtual world without impacting the efficiency at the workplace. It is the information technology that has allowed us to work having the flexibility in our time schedule. It is the information technology that has allowed us to have this international conference so beautifully organized by the organizing committee of ICMMIT of AUJ Ranchi. The people from the entire world, the scholars from the entire world, we have gathered here to exchange our new knowledge that we have acquired through researches. Looking into the product market, again, I could say that it is the information technology which has changed the face of the product that we are having. The products are so customized. It has become so consumer centric. The consumer's preferences, choices are reaching to the manufacturer, to the producers so quick that today you think of a particular product and tomorrow it is at your doorstep. The machine learning, the artificial intelligence, it has started reading the preferences of each and every one visiting the virtual market. What type of what color of, what shape of, what nature of product the consumers are looking for. It is reaching to the manufacturer, and the design is immediately created, taking once again help of technology, and tomorrow the product is with the consumer. Earlier it was not possible. It was taking years and years to customize the product as per the consumer's preference, as per the consumer's choices. This is all happening just because we have synchronized our life, we have synchronized our activities with the technological upgradation, advancement, and especially with information technology jumping into our life space. Now we are in the global market. This is all possible because of the information technology. The man and the material and the machine across the world is reaching us. Today, the people are getting the sample here. The reading of the sample is done, and then the entire prescription is being prescribed by the doctor sitting there in the United States of America. The telemedicine has started taking place. This is not possible if the information doesn't reach at the quickest possible span of time. The people are falling sick here. The doctors are clinically testing, observing, lab works are conducted, and then the entire data is reaching US, and from US, the doctor is recommending the best line of treatment. Or the doctor of India, they are recommending the best line of treatment there in US as per their expertise. So we can say we have got the global market, not only for the product, but for the services as well. The investors, pan world, they are investing in all different sort of companies and new openings. This is all possible because of the information technology. Same thing is there in the field of education as well. The researchers, the research and their research outcome, it is reaching to the community without any lapses of time. This is again possible because of the information technology, advances taking place in the field of information technology. Even the education, the basket, the new education policy that talks about the basket of the subjects, basket of the courses that can be offered, and the students, they are making a choice that I will study course X here in IMIT University, Jharkhand, and course Y there at the university at Hazaribagh, or there at the Massachusetts, and they are getting different courses from different parts of the world. This is all because of the information technology. This is all because of the virtual education that we are getting. And not only the theoretical parts, I am amazed during the Corona period, the entire world education, especially higher education, they were relying so much on the virtual labs. We got different softwares that is creating three-dimensional laboratories where the students are conducting researches, they are recording their all the readings, and then they are analyzing entire things and getting back with their outcome. This is amazing. And this is all because of the advancement taking place in the field of technology, and more specifically in the field of information technology, which is not only conducting so smoothly entire things, but also making everyone aware of what has come out of their endeavors. So I'm really happy to welcome all the scholars at this particular platform. I'm congratulating the members of the organizing team for organizing this beautiful international conference. And I feel I extend my deep indebtedness for the Honorable Vice Chancellor, Vinoba Bhave University, Hazaribagh, for sparing his valuable time and gracing the occasion. I am thankful to all the presenters who are going to present their research outcome, and they are going to update we all with their research endeavors, and they are going to enlighten us with the new outcomes that they have got through their researches. I wish all the success to this coveted conference. And with this, I extend my heartfelt gratitude for Honorable Founder President, sir, Honorable Chancellor, sir, Vice Chancellor, sir, our Registrar, sir, and all the senior members of the Amity management there at headquarters, Ramachandran, sir, and Gaurav, sir. Thank you all. God bless each one of us. Thank you.
Thank you so much, sir, for saying it and putting it so beautifully. May I now request Joint Co-Chair and Convener, ICMMIT 2022, Dr. Praveen Kumar Singh, Program Leader, Mechanical and Automation Engineering, Amity University, Jharkhand, to kindly share the session details and introduce the keynote and plenary speakers to the audience. Over to you, sir.
Thank you, ma'am. Am I audible?
Yes, sir.
Is my screen is visible to all of you?
Yes, sir.
Okay, thank you. Good morning to our Vice Chancellor, sir, Professor Dr. Raman Kumar Jha, sir, respected Director, sir, Professor Dr. Ajit Kumar Pandey, sir, respected Registrar, sir, Dr. Prabhakar Tripathi, sir, our Chief Guest of the session, Honorable Vice Chancellor of Vinoba Bhave University, Professor Dr. Mukul Narayan Dev, sir, our Program Coordinator, Dr. B. Samanta, sir, the esteemed keynote speakers, esteemed faculty members, and all the participants. I, Dr. Praveen Kumar Singh, as a convener of the conference and on behalf of organizing committee of ICMMIT 2022, would like to welcome all the dignitaries, researchers, faculty members, authors, and participants in the two-day long international conference on materials, machines, and information technology. In this presentation, I will be sharing the brief about the conference among the participants. As already discussed in this conference, all the paper will going to be published in two reputed journals. One is Elsevier Materials Studio Proceedings, which is published, which is basically a Scopus Index journal, and another is IOP Conference Series. The editors of the Materials Studio Proceedings are following: Dr. Praveen Kumar Singh, Assistant Professor, Department of Mechanical and Automation Engineering, Amity University, Jharkhand; Dr. Joyita Ma'am, Assistant Professor, Chemistry Department, Amity University of Jharkhand; Dr. Diego M.F. Santos, he is our foreign editor, Associate Research in the Center of Physics and Engineering of Advanced Materials; Mr. Abhijit Singh, Assistant Professor, Department of Mechanical and Automation Engineering. For the IUP conference, following are the editors: Dr. Jaita Ma'am, who is Assistant Professor in Chemistry Department in Amity University, Jharkhand; Dr. Biswarup Samanta, Assistant Professor, Department of Computer Science in Amity University, Jharkhand; Dr. Praveen Kumar Singh, myself, Assistant Professor, Department of Mechanical Engineering, Amity University, Jharkhand; and our external editor is Professor Dr. Amandeep Singh Sahi, sir, Head of the Department of Mechanical Engineering in Sant Longowal Institute of Engineering Technology, Centrally Government Fund University. So, further, it's my pleasure to introduce all to our esteemed and eminent speakers for the different parts of the globe who have come from to share their knowledge and vast experience. So the first speaker is Professor Dr. Mukul Narayan Dev, sir. Professor Dr. Mukul Narayan Dev, sir, is presently associated with as a Vice Chancellor of Vinoba Bhave University, Jharkhand. Sir was Head of Atomic Molecular Physics Division at Bhabha Atomic Research Center, Mumbai. Sir also served as a Professor of Physics and Chemical Science at Homi Bhabha National Institute, Mumbai, India. Sir will deliver his lecture on Fourier transform spectroscopy, a versatile technique. The timing and links details are present in the slide, and the session will be start from 10:40 to 11:40. The next speaker is our Vice Chancellor, Dr. Raman Kumar Jha, sir. The topic of the session will be quantum computing. The other details are mentioned, like link of joining is mentioned here, and the session is on 25th of January from 2:30 to 3:10. The next session is by Dr. Chenupati Jagdish sir, professor and research school of physics, the Australian National University, Canberra, Australia. The topic will be semiconductor nanostructure for the optoelectronic applications. His session is on 24th today from 12 p.m. to 12:40. Our next speaker is Dr. A.S. Sahi sir. He is deliver his lecture in the track 2 on the same timing from 24th of January. Sir is professor of Department of Mechanical Engineering from Sant Longowal Institute of Engineering and Technology, Punjab, India. His topic is on material characterization of engineering materials used for critical applications. The link is available on your screen. Our next guest speaker is Dr. Rakesh Ranjan Singh. Sir is Senior Software Engineer at Microsoft, Washington, USA. Sir will deliver his lecture on Azure DevOps. The link is mentioned in your screen. The session will start on 24th January today from 12 p.m. onwards. This session will be held in track 3, room number 3. Next speaker is Dr. H.L. Yadav sir, Professor of Department of Physics, NIT Jamshedpur, Jharkhand. The topic which delivered by the Dr. H.L. Yadav sir is engineering applications of lasers. The session will start on 24th of January, 2:30 to 3:10. The link is visible in audio screen. Our next speaker is Dr. V. Ganesh sir. He is a principal scientist of Electronics and Electrocatalyst EEC Division, CSIR CECRI, Tamil Nadu, India. The topic on which Dr. Ganesh sir will deliver is structure and morphological engineering of materials for biosensing and electrocatalytic applications. His lecture is on 24th January and the timing is 2:30 to 3:10. The next speaker of the day is Dr. Deepak Kumar, Associate Professor, Department of Mechanical Engineering, Centurion University of Technology, Andhra Pradesh. The topic on which Dr. Deepak will deliver his lecture is on additive manufacturing technology, opportunities, and the road ahead. His lecture will start from 2:30 to 3:10. Our next speaker is from Korea, Dr. Lailesh Kumar, Senior Research Scientist, Pine Tree Post Magnesium, South Korea. The sir will deliver his lecture on effect of novel processing techniques, powder metallurgy, surf plastic deformation, hot deformation, fin roll casting, and welding on the mechanical properties of lightweight materials and steels. His lecture is on again 24th of January from 4:30 to 5:10. The link is available on the screen and already shared with all of you. Our next guest speaker is from Portugal, Dr. Diago M.F. Santos, Associate Researcher in Center of Physics and Engineering of Advanced Material, the Institute of Superior Técnico, Portugal. Sir will deliver his lecture on electrochemical engineering bridging the gap between academia and industry. His lecture is on 24th January, 4:30 to 5:10. Our next session will be delivered by Dr. Professor Rajiv Srivastava sir. Sir is a professor in CSE and Dean of Resource and Alumni Affairs, IIT BHU, Varanasi, India. The sir will deliver his lecture on research applications of AI, ML, and computer vision. His lecture is on 24th of January, 4:30 to 5:10. Our next eminent speaker is Dr. Chandan Singh. He is an assistant professor, Department of Biochemistry, Banaras Hindu University, UP, India. The topic on which he will deliver the lecture is Atomic Scale Insight about Bones in Absolutely Native State. His lecture is on 25th January, that is second day of the conference, in the morning, that is 9:30 hours to 10:10 hours. The next session on the 25th January is Dr. S.R. Das. He is an associate professor, Department of Production Engineering, Veer Surinder Sai, University of Technology, Odisha. The sir will deliver a lecture on machinability, study of austenitic steel under various cooling lubrication strategies. The session will start from 9:30 morning to 10:10 hours. Our next speaker is Dr. Anup Nandi sir. He is an assistant professor, Department of CSE, NIT Rourkela. The sir will deliver the lecture on emerging trends of machine intelligence techniques in healthcare applications. His lecture is on day 2, 25th January from 9:30 to 10:10 hours. The next section is Dr. Santosh Kumar. He is from South Korea. He is a research professor at Konkun University. The sir will deliver his lecture on porphyrins, colors of light. It is, I think, very innovative and new topic. And it is the timing of the session is on 25th of January from 11:40 to 12:20. Our next speaker is from NIT Jamshedpur, Dr. Professor Sailendra Kumar sir, Professor of Department of Mechanical Energy, NIT Jamshedpur. Sir will deliver his lecture on modeling of heat exchanger. His lecture is on day 2 from 11:40 to 12:20. This link is available on the screen and already shared with all of you through the schedule. Our next speaker is Dr. Sangatharan Godbole sir. He is an assistant professor from Department of CSE, NIT Warangal. Sir will deliver his lecture on protecting software vulnerabilities from hackers using fuzzing. His link is available on your screen. The session will be on second day, that is 25th of January from 11:40 to 12:20 hours. And at the last, we have a validatory session. The chief guest of the validatory session is Professor Dr. Silva Murthy sir. Sir is the president of MIT Science and Technology, Director General of MIT Science and Innovation Center, Chancellor of MIT University Chhattisgarh, and Professor for Life Sciences. Sir was associated with DRDO as scientist and Chief Controller of R&D cell at DRDO. So it's a great opportunity for all of us to gain knowledge and learn from the experience of the keynote speakers. Here is a Zoom link summary, or we can say a summary of overall session where you can just join, just click on the given links and join to the particular session. All the keynote speeches and speakers are divided into separate rooms and virtual rooms. You have to check just your schedule and go to that particular room. Thank you. And all the best to all the participants. Thank you, sir. Over to Tanisha ma'am.
Thank you, sir, for giving the in-depth knowledge of all the sessions. A long list of wonderful experienced speakers and very interesting topics awaits for us over the next 2 days. May I now request the joint patron, ICMMIT 2022, Professor Dr. Raman Kumar Jha sir, Honorable Vice Chancellor, Amity University, Jharkhand, to enlighten us with the inaugural address. Over to you, sir.
Thank you very much, Dr. Kundu. Seeking the blessings from the founder and the set of founders of Amity Universe as a whole, I pledge and commit to them our commitment to the development of science and technology through various interactions, collaborations, and the conferences of this type. Seeking the blessings of our own Chancellor, Dr. Ashok K. Chauhan, and Founder President, along with our Chancellor, Dr. Atul K. Chauhan, and our Senior Vice President, U. Ramachandran sir, and the Vice President. Unfortunately, they have not been able to join today. Maybe they'll be finding time to join in between, Gaurav Gupta ji. And the most coveted person today with us is the Vice Chancellor from Vinoba Bhave University, a person from physics. I would love to meet him in person as well. And we are awaiting a galaxy of experts from all the areas of technology, material sciences, as well as the machine as a whole, a very common word utilized for technology. Now, having seen the life in Amity through one of the virtual journey that were shown, we see that life is blossoming at Amity, and it cannot happen without the collaborative efforts in the area of creation of knowledge, sharing of knowledge, collaboration for innovation, and contribution in whatever manner, maybe small, big, to this particular arena, which is ever growing. That we have our limited space is all right, is accepted, but that we have an infinite space on our upper portion called the brain and the mind, and its manipulation is something that we are ignorant about. In fact, it is said that it is ignorance which is the basis of all the problems in the world. Now, if we remove even some part of the dirt, or maybe enlighten that with the illuminating thoughts and creativity, there is going to be a huge change in the way we live, in the way we interact, in the way we learn, and in the way we ultimately lead our life to the ultimate bliss that we all aspire to be in, and the happiness that we are alive. I'm drawing a picture wherein why is it that we are here, not on a virtual platform like this, but on the globe as a whole. Is it not a real surprise that a virtual platform like this has people contributing from various countries like Australia, US, Korea, Portugal, truly international in nature? It's all the magic of the technology and the way the ignorance of the earlier aspects of utilization of these material machines have been removed. Now it is practical. Now it is seen, and we are enjoying the fruits. Welcoming once again our Vice Chancellor, Dr. Mukul Narayan Devji, for gracing his time for us and giving us the fruitful lecture which we look forward to. Let me draw a picture of something which we may call it philosophy, we may call it understanding, we may call it appreciation of existing set of things which exist, and then with an open mindset, there's one thing which is most important, is the power of taking decision. And I'm a very strong proponent that even if you're not doing anything, take a decision to not do anything. That's okay. If you have taken a decision not to do anything, that's absolutely fine. But if you have not decided anything, that is the worst thing that we are doing. So take your decisions, and it has huge power. If you decide tomorrow that you will be on the moon, maybe after 2 years, 3 years, maybe your direction towards that will open up. And that's how the whole community will come together. Somebody thought of this particular conference, and we have more than 300 people attending this virtually in this particular odd situation. That decision matters. Rest all will come and together. There will be many collaborators, the people contributing to finances, to their own ideas and innovation, and then together we can move. So that's one. Second is, there are three words which now are catching my attention. One is the truth. Now, science and technology, or knowledge as a whole, is searching towards that, or inching towards that truth. What is that ultimate truth? If you understand the truth, the properties, the characteristics, the behavioral pattern, the interaction pattern of material and the machines and the technology, you reach the ultimate utilization on practicality of application of the things. So the truth is very important, and hunt for this truth has been for almost 5,000, 10,000 years, and where we are today we can see. Then the knowledge itself, extension of the existing knowledge, is only through research and innovation, and that cannot happen unless we think of establishing 3-4 important criteria. I have coined it as ABCD. If you see first A, what is that A is the advanced creativity that you have to think. Normal creativity will not create any knowledge. So it is A is for advanced creativity and maybe collaboration, coordination between institutes and between similar thought process people. B, it is the bold and balanced approach. If you're making a very bold decision to jump from 50th floor directly, that's a bold decision, but is that a balanced decision? What would you achieve of it? Are so much of resources available that you don't lose and gain only? So the B is the balance. The C part is the critical thinking. Having seen so many problems all around, now the problems are galore, and there is a very clear communication of the problems also existing, expertise also existing. Now the time is only to take a decision, and D is for the decision that I began with. So with these 3-4 terms, we can and we are equipped by Almighty to enjoy the fruits of the connectivity, the application aspects of the products which you developed out of the balanced approach and the theory behind it. A lot of problems still remain unsolved. Now, some scientists have put together some ideas which are very important, especially for those who are leaning towards research, and that's why I thought it wise to share those. It is not just the individual creativity which is now important. You will have to be collaborative. Your approach has to be collaborative. Therefore, joining hands with number of universities, number of colleges, number of people. So individuals are important, but when they join, they add on value, which is more important in the present age. Understanding the process, the structure, and the function of all aspects is the next part. See, many a times we are so lazy, or we are maybe caught down because of the regular work that we are doing otherwise, maybe routine work that we are being given because of the work that we have taken up. Research takes a back seat. No, that's where we falter. Research is something which is your own product of your own existence, maybe after you have gone or you have taken the next birth. How will you exist in this particular life even after you have taken another birth is research. Now, can you lose this opportunity of not doing something to exist even later? That's the question that you should ask and then take a decision. You will have to find excellence gurus like Professor Dev, one present here. The gurus who lead you to excellence is now less in number or in scarcity. Either become that guru or search one and be with him, or maybe together you formulate a set of guru system wherein all ideas are shared in an open manner. Something or the other new is going to obviously come out. The leadership or the guru that I said in terms of the science and development takes care of the balance of the following. What are those things that we have? Now you will have to go away from the Boolean thinking that we had. Zeros and ones are gone. So there is going to be a coherent thinking, overlapping thinking, wherein not just one discipline becomes important and its extension, but maybe one discipline interferes with the other fields as well, and you will find patterns in those interference or the interdisciplinary or multidisciplinary approach, which is what is being propagated now. So you have to find a balance wherein can you impact other areas of study as well or domain. Second, the basic science and the applied science, there is need for a balance. Material science, that is nothing but physics. The whole mechanical engineering came out with the balance of the theory which exists and the properties of the materials that you have. So if you make a balance, you have made everything. You have reached the moon, and you are trying to, I was only yesterday seeing a monkey was trying to play a game on the computer by one of the, I think that was a neural link by Tesla owner, what is his name? Elon Musk. So the monkey is now being trained to play games and balance the key there. What does that mean? If a monkey's brain, which is so turbulent, can be balanced, well, we are already balanced to a great extent. The need for spirituality and meditation, of course, exists. It is your body, yes. It is your mind, yes. But you got to decide how to use it. That's where balance comes in. You have to have the balance between the relevance of a particular thing and the depth of knowledge that you have. It is not that I know a lot of things. No, there is a need for relevance. Is that particular thing relevant for this particular thing? You add value. That addition of value is research, is new, is your maybe innovation. Then application has to be brought into this. There's another thing which is very important, even though not said in the scientific parlance. It is the sympathy and the understanding of each corner of society is very important. Even though we may claim that we have done this or that, but if you're not sympathetic, if you're only selfish, if you don't have the empathy and the compassion for people all around you, your work may fall flat. See, a lot of us were gathering a lot of money and whatnot. Today, money is in the pocket and everybody is inside his own socket. What has happened? So the nature is more important and togetherness is more important than scientific discovery. And with togetherness, you can have more discovery and diversity can be balanced and then known clearly or maybe in a much better manner. Accepting change and experience sharing is another good idea and the best idea in the present scenario. We must practice this. People say science is dogmatic and it does not change, but it is the only thing. And it is here, I started with saying that ignorance is the basis of all the problems. Now I change, or maybe I modify. Ignorance is bliss for scientific research. If you don't know something and then you know that you don't know, then take a decision to know. You will know. So it is not that ignorance as such has to be negated or has to be put down. If you're ignorant about things, that's better. That's a bliss. People are more worried, or we are more worried that people know that they know more. That's where we falter. Please get back to your own stream of expertise, yes, which is a requirement, but then the balance and the support system from everyone is a must. Coming to the developments that we have seen all around in the area of technology and especially the artificial intelligence and machine learning, we do understand that we have crossed from industrial revolution 1 to now 4, and now we are also talking about 5, wherein there is going to be an integration of all existing knowledges. So therefore, anything that you know, if you're an expert in that area, throw your cards open and be open to interaction with anybody across the globe. If you're open, you're opening the door to innovation. You're opening the door to creativity, a new generation which is dependent on what you do today without losing the opportunity of remaining with the new generation. I think research and development, innovation is a must. And I'm extremely happy to see the contributions of more than 150 papers and so many experts from all around the country and the globe coming and willing to contribute and sharing information. And therefore, IMIT University is proud once again with all its humility to welcome you on this platform, to welcome your contributions in all areas that you think are important. No idea, no matter how small, is a bad idea. So if you take a decision to share your idea rather than being traditionally, we were all caught down or we are still worried about my publication rather than team publication. We are worried about my IPR. Can my work be recognized and my name be on the top? All the names go away when you are not there. I visited the Smashan Ghat only yesterday. That is why I'm reminded of life every second. So it is your life and you make a contribution. Nobody can erase you from history. You have seen Subhash Chandra Bose coming up after so many years only yesterday. So you must make a mark in the area that you are. History will remember you for your contributions and togetherness. The production of whatever you do in terms of creativity or product that you have made must also come to mass consumption, or to bring that to a mass level wherein they really matter and change the society. So this is change which is important, and your decision to make that change is the most important thing. I will sum up by saying that we understand that India is the largest higher education setup. I'm sure you know it. We have almost like 1.4 to 1.5 million schools, around 30 to 40 crores of students studying, around 50,000 colleges where the functioning is going on, and almost 900 universities which are functional. Now, if this is the arena, each individual, there is an atom bomb. Each individual can create an energy and synergy of the kind that the whole society who is not part of this particular teaching community should salute teachers forever. And that's what is our aim when I said about excellence gurus. Combination makes you gurus in a better manner. Collaboration makes you gurus in a better manner. University coming up openly, utilizing the resources of others can be a very good matter, and the new education policy allows us to get into this not only nationalization but a globalization of educational and sharing of information. After 1990s, we have seen that the e-learning market has also increased to the extent of $50 billion. Now, which also means that this platform where we are now sharing is going to expand even further. It is not this normal internet that you have seen has made so much of impact. Please be ready to welcome quantum internet maybe another 50 years from now. Another 50 years. It's not big. It's not within your generation you can see. So if you have quantum internet coming in, well, sky's the limit. And that is where I thought to bring in this topic, because I'll be speaking on this, maybe elaborating a little bit of mathematics and physics and aspects of technology where we are today as far as quantum computing is concerned. This conference can be one of those conferences where the publishers will also think about the quality, and everyone associated is going to gain. My thanks to everyone who came. If you want me to continue, I can, but then I think I have to end at 10:40, 2 minutes I have. So I would add on to say that the government today, in the form of new education policy, has already brought in this idea of openness, multidisciplinarity. There is nothing like this university is the most important. Any person who is the best can be giving the lecture, and anybody can receive his lecture and the credits. There's going to be an academic bank of credits for the student, and they can get their degrees from anywhere, wherever they feel like. So there are some modalities to be worked out still. So some important things which I would like everyone related to academics to understand, that understand the power of thinking. Think and think and think. If in a month you read one book, start reading 3 books. If in a month you are thinking for maybe 1 hour, start thinking for at least 30 hours. 30 hours a month, start thinking, you will see the change. And then 90 hours meditating. I said 3 books, 30 hours of thinking, and 90 hours of meditation. 1:3:9. So 3 times. So if you study for 1 hour, think for 3 hours, and meditate for 9 hours, which means you think about the application and brood over the problem. Approach to problem solving would naturally solve your problem. If you cannot find a problem in this world now, with the internet and information technology available, there is a problem in your brain. Please go to the doctor. Please go to the doctor or to the excellence gurus, because you have not had gurus. That is why you are still lost. Ignorance is a bliss, yes, but ignorance is the root of all problems also. So remove this ignorance, come to the arena of knowledge, come to the arena of innovation, and that will meet the real aim of this particular conference also. Thank you very much for the opportunity given, Dr. Kundu, Dr. Samantha, and the whole team of experts from ASSET as well as AIIT from MIT University, Jharkhand. Today, I'm proud to tell the world that MIT has wings. You can just get onto that wing and fly together. Thank you very much.
Thank you so much, sir, for the highly engaging and speech and charging us up. And we always find the guru that you were talking about in you. So thank you for that as well. Now, may we proceed further? May I request our joint co-chair and convener, ICMMIT 2022, Dr. Joyita Chattopadhyay, ma'am, University Coordinator, Research and Development Cell, Amity University, Jharkhand, to kindly welcome the chief guest of the day, Professor Dr. Mukul Narayan Deo, sir, Honorable Vice Chancellor, Vinoba Bhave University, Hazaribagh, Jharkhand. Over to you, ma'am.
Thank you, Tanisha ma'am. A very good morning to all the respected dignitaries and participants. I, Dr. Joyita Chattopadhyay, would like to take the opportunity to read out the short profile of Honorable Vice Chancellor, Vinoba Bhave University, Professor Dr. Mukul Narayan Deo, sir. Professor Dr. Mukul Narayan Deo, sir, is currently working as Vice Chancellor in Vinoba Bhave University, Hazaribagh, Jharkhand from June 2020. Professor Deo worked as head Atomic and Molecular Physics Division and as scientific officer H+ at Bhabha Atomic Research Center, Bath, Mumbai. She has worked as professor of physical and chemical sciences at Homi Bhabha National Institute, HBNI. She has been involved in high-level research and development works of more than 33 years at BARC, Mumbai. She is a postgraduate in chemistry from Benares Hindu University and PhD with specialization of physical chemistry from Mumbai University, India. He completed his postdoctoral fellowship from IAMS, Academic Senica, Taiwan, and Nobema Radio Observatory, Japan. He had also worked as visiting scientist at Okayama University, Japan. He has also visited various reputed research organizations and universities in Italy, Germany, US, etc. His research domain covered physics of materials under extreme conditions, atomic molecular spectroscopy, spectroscopic techniques like Raman spectroscopy, Fourier transform spectroscopy, X-ray diffraction study, etc., and synchrotron radiation-based techniques, etc. He has published more than 100 research articles in various journals of international repute. Thank you, sir, and a very welcome to Amity University, Jharkhand. And over to you, sir. You can share your presentation now.
Sir, please unmute your mic.
Yeah, thank you for a nice introduction. And dignitaries present on this virtual platform, Professor Dr. Raman Kumar Jha, Vice Chancellor, Amity University of Jharkhand, Professor Dr. Ajit Kumar Pandey, Director, Amity University, Jharkhand, Dr. Parveen Kumar Singh, convener of this ICMIT 2022 and program leader, MAE, Amity University. Dr. Biswarup Samanta, joint co-chair and convener of ICMMIT 2022. Dr. Biswarup Samanta, okay, now Mr. Prabhakar Tripathi, organizing chair of ICMMIT 2022, Registrar, Amity University of Jharkhand. Key speakers, participants, students from India and abroad, invitees, press, media, personnel. Very good morning, very good afternoon, and good evening to all the participants of ICMMIT 2022, International Conference on Material, Mechanics, and Information Technology 2022. I thank organizing committee for giving me opportunity to share some of my experience, what I have carried out last more than 30 years to you here. Now I'm just, my topics is today's talk is Fourier transform spectroscopy, a versatile technique. Now my focus will be around this, just to discuss its versatility. Though during my talk, I'm going to show many examples that belongs to some other areas. That is not possible to discuss each and everything here, but just my aim is to show that Fourier transform spectroscopy a versatile technique. Now, I have planned my talk like this. Why Fourier transform spectroscopy or spectrometer needed? What is Fourier transform? What is the principle of FTS, Fourier transform spectrometer, interferogram, spectrum, application of FTS, materials to molecules, atoms, and others, and factors which affect the observation. Now, as you know that before 70s, most of the spectrometer was based on grating, means dispersive base. Like a source goes to the grating and then dispersion takes place and then comes to the detector and then we get the directly spectrum. But it has certain limitations, and a limitation, major limitation is resolution is very limited of grating based instruments. Like best, ideally one can get 0.01 wave number. Secondly, that at a time, because it is a sequential base, dispersing elements are there. So at a time, only one wavelength is measured. So it is really, it takes much time to record the, even to cover very small infrared region like 400 to 4000 region. And sensitivity is very poor for this instrument. Of course, one of the major problem also comes from the straight light problem. Light scattered from the samples or any other some optical components that falls on the detector, and that ultimately gives a noise. And always you need to external some for wavelength calibration, you need a calibrating source. So these are the some problem. To overcome these limitations, FT-based spectrometer was developed. Now, first, before going to the detailed part, what is Fourier transform? You know, everybody here that Fourier transform's name has come, it is nothing but because of the mathematical process that relates the measured signal in one domain to its components in another domain. Because what we get from the experiment, but directly what we need a frequency domain spectrum, and what we get here some other domains. So to convert from one domain to other, we need this Fourier transform. That is why these techniques are called Fourier transform. Now, there are various techniques nowadays is based on Fourier transform. Like optical region, there are FTS, or most of the people you know that FTIR, but that is limited to only the infrared part. But FTS generally we talk entire optical region, means far infrared to UV region. And of course, there Raman also, Raman depends. This is also laser technique, but it is based on the FT. And there are FT microwave, FT NMR, FT MS, or FT electrometry, etc. There are so many techniques based on the FT. Now, actually in optical region, basis of this Fourier transform is nothing but a Michelson interferometer. And you know very well that what is a Michelson interferometer? It is just two mirrors. One is movable mirror and another is fixed mirror. Light comes from this beam splitter, split into two parts, recombine, comes to the sample, and then it detectors. So here we get we can vary the path length. So as a varying path length as a function of delta, that is optical path length, and we can measure the intensity what we receive here. To get the idea of the path length, where that position of the mirror, we same time helium neon laser is used. Now, what we get experimentally? We get experimentally, this is called intensity as a function of delta. That is the optical path difference. And that is what we call interferogram. This, to get the spectrum, we take the inverse Fourier transform, and that is nothing but as a intensity as a function of sigma, that is wave number. So in grating base, because since their dispersing element are there, we get directly spectrum, frequency versus whatever intensity. But here we have to convert the signal into the required spectrum, that is frequency versus wavelength. Now this is one of the typical interferogram, as here we have shown here. And so from this we see that it is not possible to interpret this. And just to convert this, you have to take the Fourier transform, and then we get the spectrum. Now, we have to consider this equation. This is practically it is not possible to implement in the instrument while recording, because there are many things. See, minus infinity is minus infinity to plus infinity, means mirror is moving from minus to plus infinity, very longer wavelength. Second is we are integrating. So it means that it is practically it is not possible, both, because minus to plus infinity, it is not. So we have to truncate the interprogram, and that gives some, we have to rectify that problem. Secondly is data collection is not continuous. It is a discrete in nature, because every detector has own processing time, that what we call it dead time. And during that time, no data is processed. So we cannot use integral. So we have to convert into summation. So these are the practical limitations. So interferogram is not infinite, it is a finite length. And because of this, some optical mismatch, that what we get the interferogram. Here we just shown that it is a symmetric, but actually we get asymmetric because of the some disturbance during the recording because of the optical components. So that is what, so it means we cannot take the directly Fourier transform. So we have to do the discrete Fourier transform. So discrete Fourier transform is nothing but is a, now you have to change the integral to summation, and then it comes to the data points n, and then we have to do the DFT, discrete Fourier transform. But later on, just I'll say that this is very time consuming because data comes, huge data is coming through this recording. It depends that how much region you are covering at a time. And in 80s, it was not possible, very high resolution, just very short range, maybe just 50, 60 wave number was possible to cover. Because that time is computer speed, memory, RAM, it was limited. So that time it was the restriction. Of course, this was possible only when FFT algorithm was developed. That is 1965. That is a Cooley and Tukey. They developed the algorithm of FFT, and that is nothing but is a n log base 2n. When this was developed, then drastically that operations, that time for converting Fourier transform was drastically reduced. And then it was possible only that after the development of this FFT algorithm. And then, so 70s, only limited instruments were, these FT-based instruments were available all over the world. But later on, when that computer speed and that advancement in the electronics industry, then because of that speed of the computer high, memory was high. So because of that, then it was feasible. And nowadays, almost more or less, almost all the labs converted into FT base. Not any now lab has grating based instruments. Now, but this has some problem, as I discussed that this has minus input to plus input here limit. Because of that, because we are not scanning the mirror from infinite length. So it means we are truncating, and because of that, some side lobes appear. So what we have to use a appropriate apodizing function. Apodizing function is nothing but to take care the length, finite length. We have to multiply a apodizing function to the whatever observed that data, and then we do the Fourier transform. But because of this, spectral line width increases, and here we have just shown here that what is the effect of apodizing function. And here is ideal case, means if you have recorded infinitely big that interprogram, then we get a ideally without any width. But when you truncate without any apodizing function, we get a side lobes here, and that sometimes it is confusion creates that whether it is a genuine peak or a real peak. So we use some apodizing function, and then we get this type. But here, as compared to here, there is a width increases. So there are some apodizing functions available in the instrument, commercial instruments. That is a boxer, no apodization, triangle, or there are so many Hamming. Here, just I would like to say that because while, as I stated here, because experimental condition is very important, and that what you scientific conclusion you get from these depends on your experimental observation. If appropriately, if you not correctly selected the parameter of the instrument, then what result you will get that may differ what you are means missing there. So it means is a selection of various instrumental parameters is very important, and that is why ordinary this operator cannot do this type of work. And for this type of work, you skilled person is required. Now here, spectral resolution also depends on the optical part difference, reciprocal of these. So here, because as I just said that it also, when you use a apportaging function, line width increases. And also because to control the divergence, you need a very small aperture. And other, of course, these are the not, it depends on experimental Doppler broadening also depends, because temperature dependent, and power broadening, if it is any microwave or DC discharge is there, then that also broaden the lines. Collision broadening, source instability or self-absorption, HFS, these are the other factors which can broaden the line width. Now here, most common source are there. Mercury source we use 10 to 500 wave number. Global source in the mid-infrared region. Quartz halogen we use this range. Visible, part of visible, and deuterium ramp for UV region. But very special source, that is what we call synchrotron radiation, that covers the entire range, means entire optical region, not only optical region, even one can go very short wavelength region, that is X-ray region. But here what our interest is optical, we are covering the optical region. So this entire range can be covered by single radiation source, that is synchrotron radiation. And you know that each country now they have already running, and India also we have the synchrotron source at RRCAT Indore, Rajaramanda Center for Advanced Technology, that is part of Department of Atomic Energy. And we have two synchrotron source there. One is Indus 1, that is a energy is 650 mega electron volt, and one is 2 GeV electron volt. So these are the two sources, Indus 1 and Indus 2, already it is running there. There are many beam lines already set up there. And of course, one infrared beam line is also, in fact, I set up there for that. And it is already, it is operational. So this has a very broad range, synchrotron range. It can cover infrared to X-ray region. And here, what is the advantage that synchrotron is used? Here, high brilliance means very high compared to far and mid infrared, up to 10 to the power 3 order of magnitude you can get higher, wide wavelength coverage, and high degree of polarization. These factors is matter because especially when you are doing certain measurements where that intensity goes into the sample is very small, especially that I will just show some of the spectrum where you need such type of very high intense beam. Why you need that, I will just show you that something. So this is the example here we are showing. This is the spectrum recorded. Blue is for globar, normal source heat, that is a just heat a silicon carbide rod, and you get that is nothing but it is a globar source. But when you use a synchrotron, then you see the noise level is very, very small. So that is an advantage. So now here one spectrum has been taken here. You see the width synchrotron quite intense, high intensity is there. So means you can get very high signal to noise ratio using this. Now here see some of the important factors is there, because see here is a covering the entire wavelength at a time, means data is each data points has the information of entire wavelength. It what it means if any fluctuation, fluctuation in one of the wavelength, if creates, that will spread to entire range. That is why this type of instrument, when especially using source which has fluctuating, it may fluctuate, not like glow bar, it is just a heating element, you can heat and stabilize after some time. But like a synchrotron source, because it is emitted by the electron what moving in the orbit, so that is stability of that source is very, very important for, especially for a transform based instruments. Because of this, because it is each data point has the entire wavelength information. So any disturbance is one of the wavelength, it will spread to other wavelength. So now here there are because the beam splitter is very important component of Fourier transform in optical region, and there are this type of beam splitter has because this is a material dependent. So one material cannot means transmit all the entire range. So one has to use certain materials for particular. So selecting these things is very important. Appropriate selection, or even if someone is going to set up a lab, then what systems he should buy, because this type of instrument is the cost varies from 20 lakh to a few crores, like 4 or 5 crores. It depends that how much region is covered and what detectors you want, what sensitivity work you need, what results you are going to get, and so means ultimately what requirement you are, that will decide that what type of equipment you will buy that. And so these are the things that you need to buy this all. If you buy all means range, you can increase that. And these are the detectors. There are set of detectors are available. This is also here, I just would like to point out, this is very, very important part when you are get something you are doing, because you know this spectroscopy, this technique is it can be used many areas, biology, life science, or material science, or physics, chemistry, geology, many areas. I will give some examples. So means what type of work you are going to do, accordingly you have to decide which detector you have to use. Also it depends on the area where you are, like Hazaribagh or Ranchi. Generally liquid nitrogen is not easily available, or even liquid helium very expensive. So one has to think that somewhere that you have to think whether this is feasible. Even if you buy the detector, but this liquid nitrogen, if you don't get, then how to use that? So, but of course, where sensitivity matters, definitely you have to come. You cannot compromise, because there are a lot difference in cost also, but sensitivity is very much different. Like in far IR, bolometer, silicon or germanium bolometer works in this range. This range also DTGS is there. This detector cost hardly about 1.5 lakh or 2 lakh, but this detector cost about 40 lakhs. But this required liquid helium is very sensitive compared to this detector, but you need this. If your work is suppose such type of detector required, then one has to buy. We have set up one bark. We have one. I have set up one this type of facility. We are almost having all the types of detector, because that cover the entire range, 10 wave number to 50,000 wave number. So we have this type of. So there are set of detectors. One has to see that. And cost wise, I said that even mercury cadmium telluride, very famous detector in mid IR, but this required liquid nitrogen because it works at 77K. And but cost wise, this very expensive. This cost comes about 10 lakhs or so. But this this is also here DTGS is there, this range, that again it cost is very low. So, but sensitivity is even faster, much faster than what data you can collect using the MCT, maybe the 1/16th part of that what time takes taken by the DTGS. So there are, apart from that, you have to appropriately, depends on the what experiment you are going to carry out or what information you want. So you very important is required that there are appropriate accessories required. Either you develop yourself or there are certain, there are certain accessories not commercially available, something we have to develop. If you are working in that direction, then one has to develop this. But there are some accessory available commercially like drift, ATR, means diffuse reflectance, and attenuated total reflectance, specular reflectance, photocaustic, IR microscope, diamond anvil cell, or some other special setup of particle problem. So this is very important while doing the experiment, because just take the sample and put on the beam, you will not get that. So I will just show you that is the aim of this talk. So why this instrument is versatile? That is, as I said, that see, this is first of all, this the wide wavelength coverage means one can cover from UV to far IR. If suppose compared to grating, it is very, very difficult, because this range to very big room is required. So many grating, I think maybe 10, 20 gratings required for that. Even resolution, one cannot get that. So this is a very important, because wide wavelength coverage, and also is a, while recording in one scan covers the entire range. That is the most important part. So large spectral range in one recording means this is a nothing but multimedia. Means each data points, as I said, is a contains all the information of entire wavelength. Whatever wavelength you are covering, entire wavelength covers in that. Each data points has the information. So this is a directly means speed it tells. Means in short period you can do measurement. But same thing it is with grating base, it is time consuming. So here using this facility, one can do time resolved spectroscopy very easily in the few nanosecond time resolution. High instrumental resolution, as I said, there it was limited very 0.01 or so, but here one can go better than 0.001 or so. One equipment I have set up, a bark, that is a 0.0015. Okay, now extensive data averaging, because this is because what you get the while recording that, because helium neon laser is used here, and that gives a very unique reference point, and that using a reference point, one can repeated scans one can take and take the average. By that doing the average, that means signal to noise ratio enhances by many orders. But similar case, it is not possible to grating, because when if you re-record, then it has to gratings has to go in the same position, but always backlash error will be there. No unique point you will get. So it is not possible with a grating instrument. Two scans cannot be co-added. But here very easily it is possible. So 1, 2 scan, 10 scan, 100 scan, 1,000 scans. It is very easily it is done. And some of the example I am going to show that. So that is the ability of fast data acquisition. These are the points based on this, because this equipment can be used many areas. So here, how to further how to enhance the signal to noise ratio. So that is because it's a multiplexing advantage, means all wavelengths collected simultaneously, and high throughput means compared to there in grating, what aperture you use that to take the light inside the spectrometer. Here you can relatively it is more light can be collected there, and appropriate detector one can use. Then signal to noise ratio, like if anybody using DTGS at same time, if you want to use MCT, because I said this is a liquid nitrogen base, this very sensitive photoconductive type of detector, but this is a pyroelectric detector, DTGS. So sensitive wise, this is a much sensitive than this. So if you are, suppose you are some measurement or yes some information is very weak in feature, then you have to use very sensitive detector. There is no any alternative. So depending upon the actually the measurement or requirement, one has to select appropriately which detector one has to use that. And same times, sometimes one has to use appropriate filters, optical filters, to enhance the gain of the detector. And that is very important. I will show some of the spectrum where that ordinary case, there is no any spectrum, but when you use the filter, you will get the spectrum. And of course, I said apportaging function properly, one has to use a apportaging function, weak for high resolution and strong for low resolution. Photon noise also you have to reduce, and sample quantity depends that how much sample quantity is required. Or integration time, coordination, co-addition of scans, that also you have to decide that unnecessary co-adding, that also sometimes degrade the spectrum. Now this is the one setup I am showing here. This is a this is a microscope, infrared microscope. This is a spectrometer, low resolution, and this is the cryostat, which we can any low temperature measurement one can go up to 4.2 Kelvin. So I will show some of the example that what features we can get that. And in fact, microscope very useful for certain study. I will just that also I will show you. This is the setup, what it is running here. RRCAT is in infrared beam line. And this is, if anybody actually wants to use this, one can put a proposal. And this is nothing but is a just layout of this microscope. This. And this is another high resolution, very high resolution FT system. And this is this 0.00126 wave number. And this is a long path cell is set up there here. And here is a FT Raman spectrometer. Now, I said appropriately one can select the source, beam splitter and detector. One can cover the entire range, optical range. And one example I'm showing here. So see, see this spectrum is from here infrared to 40,000, it is UV region. This is a set of detector has been used, and this is a actinides atomic spectra of actinides, and source was used electroless discharge lamp. And one can see that this type of information is cannot possible any type of technique other than this, because this is the one technique, but it doesn't mean that this is the ideal technique. See, every technique has some certain advantage and disadvantage. So here advantage is if entire very longer range one suppose you want to cover that, this type of detector technique is very suitable for this. One of the example is here. Now, so application mostly depends on the high resolution. One can do the transient species, means very short lived species. One can measure that because data collection speed is very high. As I said that one can do the means time resolved study. Both either molecular species or atoms of the. This type is very important certain places, because if certain species is interfering to another species, the two because some species has shorter lifetime and some is higher lifetime, then this technique is very useful to distinguish two spectra. And this is also possible, this is important for astrophysical importance, because many whatever the many data collected from sky, light is coming from sky and through telescope, many some of the spectrum is there, but to match that one has to do laboratory studies. So but this type of instrument is very useful for that. because coverage is wide length and plus resolution also important, and atoms, transient species, all one can do that. Of course, same times high resolution stable molecule one can do transient. This is absorption. One is emission study. Means one can do same instrument, one can do emission studies. For emission, no source is required. For internal source, not required. Your sample itself it gives a means source of source. So here absorption, you need a means internal source like a synchrotron source one can use, and one can do material characterization, whether solid, liquid, gas, analytical microscopic study, high pressure, biosciences, low, high temperature, this thing. Now I'm going to show some of these. Now, as I said that instrumental and configuration depends on information needed. What configuration you need in the instrument, that first you have to decide what information you want. Accordingly, that configuration of the instrument is set up. So, and so appropriate experimental condition is important to get good quality of experimental data. That I am going to now show some of it. Now, for some, first I will show you some emission studies. And as I said already, that sample itself acts as a source of radiation, okay? And absorption, you need internal source. Now here some just few, see, it looks very tiny, but you if you want information, like even some species like isotopes, like very rare isotopes, like that is a very minute kernel, maybe 200 to 300 microgram only available. And you need a very entire optical range, you need a spectrum information. Then if you take any laser technique also there, but then huge quantity of sample is required. But here this is a one technique, that this is a electrode discharge lamp, very tiny sample in the form of that corresponding iodide. It is kept here. You see in this, nothing is seen here. It's like a blank. But when you discharge it, then light will come out. It will act as a lamp. So that is a very, and so one can do the isotope shift, HFS measurement, transient molecule. There are so many things it is possible with this. And especially isotopes having very small abundance, that one can do by this technique. It's only this technique is possible. Okay, so this is one example I am showing here. This is the lamp. This is the discharge. This is the color is like violet slightly. Blue is this is a nothing but is a bismuth atom is inside, and another is a here iodine. This is the actually snow is a liquid vapor is passed through, and it is a means that cavity is cooled down, and this light is coming out, and this going to a spectrometer. Now I will show, this is the another type of source, is a liquid nitrogen cooled, and this is the what it is discharge, it is looking from that inside there. So this is the one features I am going. This is the spectrum of emission spectrum of iodine, and this is, see, at without cooling, if you go, you will get this feature. But if we just cool down, like just I have shown here, this is the here, then all the features will appear. So this is I said, this is experimental clarification, what you need information. If you want a full all resolution, though instrumental resolution is quite high, is enough, but because of the sample, means what condition you selected in the sample, that is not as per the means width is high. That is why if it cools down, then one can get this. Here another example. This is a normal ideal, but liquid nitrogen cool hollow cathode when it completely resolve that. Now this is one example I am showing here, that this is very important. Sometimes you need, suppose you want to know that you are enriching certain species. Like here, you know, sulfur hexafluoride SF6, sulfur 32 is about 96%. But suppose you want some sulfur 3230 is not available here, not seen at all. So in that case, you just you remove this by laser, CO2 laser. You just multi-photon dissociation, dissociate this molecule, remove then you will get the these other isotopes. And this is the one technique one can directly monitor that how process is going on or not. This is another example that is low resolution, very high resolution, then it is a part of this. This is the another gas phase. Suppose you want to cool down, then one has to take this type of arrangement, and then you get the difference. This is the room temperature, and this one is the temperature at 200 Kelvin. So this is, see the features is completely resolved here, and here it was not there. So similarly, one can do the high pressure studies, low temperature studies of materials. Now here for high pressure, you need a diamond anvil cell and some materials. You want to understand the materials under extreme condition, applying the pressure or by varying the temperature. This is a high pressure when you want. This is the diamond anvil cell. One can put a sample here, and this is 2 diamonds and gasket here, and the one can apply pressure, then light one can send from here to here, and then one can record. Here, what I said there, that synchrotron radiation is required here because they are very bright source. If a lab source you use, because there 90% light is lost, because here what we use size is about 60 to 100 micron size. And if light focus that ordinary lab source, then most of the light will waste it. But if you use, because synchrotron is very bright source and you can focus very small region, that is why this for the such type of studies you need synchrotron radiation. So here now also you people know that see all that there are various types of diamond. But see, for again, if you want to do infrared studies in infrared region, then what a natural diamond that we cannot use, because this has a very strong absorption. So you have to appropriately type 2A diamond, CVD grown that diamond one has to use there. And because this has nothing, no absorption of this. And this is the cell. This is another one can do the acrylamide, some polymer studies, high pressure, how that polymerizes. That is also possible with this such type of study. Now, here again, low pressure, high pressure, one can see that if molecules, certain molecules, if you are pressurizing, how structure is changing with pressure. That also one can monitor through this, putting the sample in the diamond anvil cell, and one can apply pressure, and one can see that that how structure, whether center in any symmetric molecule, whether is becoming asymmetric or what, or permanently converted to another molecule, another material. So this is a one we have shown varying temperature. This is up to 4.2 Kelvin. We have see some certain peaks appear. That shows that structure is slightly changing there. Okay, here I will say that you see certain metal materials like niobium is very important. You know, this is a use of high technology that is a accelerator. It is used this, but is a surface. Sometimes it degrade because of the some impurities present on that. You know, surface one can characterize. One can do the SEM, scanning electron microscope, or some XRD type. But here what we have observed that when we did that SEM, that no features was observed. But same thing, if we use FT Raman at low temperature, 80 Kelvin, then we saw that many impurities were present on the surface because of this. So actually, what type of polishing is there required, like electro polishing, that chemical polish, all different types of water because while polishing, you will not know that what impurity remains there on the surface. And this technique, one can very small portion, just cut it and you just scan it. You will see that whether impurity present there or not there. Because this is especially important for high purity material. This is, I said that one can do the time resolved studies, and this is the various time, this has a krypton D, the different time interval has gone with this. This is how it is dying, how it is forming and that one can see that. Here, one example I showed, this is a CS spectrum, but this is a long helium. This is a overlap with the CS. So because of this time result, if you use this room temperature, means without time resolve, then you will get just a result. And this is helium plus the CS. But if you do the time resolve, then this has a lifetime smaller, it dies down before, but it remains for longer time. Use of this Fourier transform, this one can use is, suppose certain industry is lying in the that residential area, then hazardous suppose gas, it may leak out, then one can directly monitor using this technique. We can open path Fourier transform. And also, if you use a solar tracker, then in the laboratory itself, one can use what is happening, what pollution or that any gas is coming out in the air, atmosphere, one can monitor this. Now I am coming to the certain, this application part I have over. Now see the certain condition. What if condition is not appropriately taken care, then your result may differ. One of the is this. See, there are three spectrums shown here. This is more samples is there, is a less sample is there, here appropriate sample. So intensity is more appropriate. So such type one has to take the here you say another same spectrum is here, but here number of scans very low, here number of scans sufficient. You see the here signal to noise ratio excellent, and here signal to noise ratio very poor. Here again, what is spectrum? Suppose very weak transition you are looking that, then one has to use very high pressure. Like here, see these bands are very prominent. For this very low pressure, 12.6 millitorr required. If you want to study these, then you need very high pressure. So experimental condition is very important. Here again, this is a normal, very low pressure. This is a high pressure. Then your line will be broadened. So your feature, what you will get, that is a distorted. Here another, that resolution, appropriate resolution also required. What resolution you want that? Here, for example, 0.5 resolution, no features. 0.05 less features, but here all the features have. But here at one, I see here signal to noise ratio very good compared to here. Here signal to noise ratio is poor. That is why here number of scans you have to take large, and here compared to low resolution. Here again is a low resolution, no features has appeared. High resolution, these features has appeared. Here one now I am showing one, see sometimes microwave discharge, people do that to get a certain spectrum. Use excess, some power was used. You see that because of the self absorption broadening, is a self reversal has taken place. Means here line has absorbed, this line has absorbed, so deep has come. So, but actually it is a 4 lines, but it is appeared of 7 lines. So if appropriately, if you not taken care that excess signal to rise is very good, but here number of lines are more, and that is a false lines. Here again I am showing here. See here signal to rise shows poor. Here signal to rise ratio more, but here you see that so more scans line broaden because this source is in unstable. Because of that discharge condition, so unstable, so more scan if you take, co-addition will be there. So that line will be broadened. Here, similar cases. Now here, sometimes you have to use appropriately experimental, like here, there are many features is missing here. But appropriately, if you cool down, then you'll get all the features here. Now, one important here, you see the here, sometimes I said in the beginning that sometimes proper filter one has to use. See, without filter, we get nothing, no lines, nothing available. But if you appropriately use the filter, then you got this. So anyway, I have something I have discussed. Now time is over. So Fourier transform spectroscopy, a non-dispersive Doppler limited technique based on interferometry, has some inherent characteristic features such as wide spectral range, far infrared to UV, very high resolution capability, extensive data averaging, ability of fast data acquisition, etc., which makes it one of the most versatile spectroscopic technique used for studies of atoms, molecule, materials, solid, liquid, gas, plasma under extreme thermodynamic conditions. These people are my collaborators, and thank you.
Thank you so much, sir. I'd request the participants to raise any questions. If there are any questions from the participant side. Otherwise,
hey, देखो, अरे कहाँ गया? उसको बुलाए?
there are no questions. So we'll move on to the next segment. I request our eminent chief guest, sir, Professor Dr. Mukul Narayan Deo, sir, to kindly declare the technical session of ICMMIT 2022 open. Sir, over to you.
मैम फिर से announcement दे दीजिए.
Hello.
Mukul
Mukul,
sir,
sir?
please unmute yourself.
Sorry.
Yes.
It
Sir,
is a great pleasure for me to declare open the ICMMIT 2022 conference and to welcome the participants from all over the world who are participating in this event to exchange their valuable thoughts. Thank you.
Thank you, sir. Now, may I request the conference chair, ICMMIT 2022, Professor Dr. Ajit Kumar Pandey, sir, respected Director, AUJ, to kindly present the vote of thanks for the session. Over to you, sir.
Thank you, Tanisha Kundu, ma'am. At the outset, I would like to extend my heartfelt gratitude to Honorable Vice Chancellor, Vinoba Bhave University, Hazaribagh, Professor Dr. Mukul Narayan Deo, sir, for the wonderful session. Even though I am non-technical, still I was enjoying the session. I was a very patient listener, and I was trying to catch at least few things of my use, and to an extent I was successful as well. I am also equally grateful to Honorable Vice Chancellor Dr. Raman Kumar Jha, sir, for his valuable presence and sharing his insight on the Guru Parampara, which was adding flavor into this international conference. I'm thankful to our fellow colleague, Mr. Prabhakar Tripathi, sir, Registrar, Vishwaroop Samanta, sir, Program Coordinator, Dr. Praveen Kumar, Program Leader, Tanisha Kundu, ma'am, for beautifully narrating the entire session. And also, I'm thankful to all the participants, all the presenters who are here and who added so much value into this conference with their presence. I'm thankful to Sumit Kumar Rohit ji for helping us out while sharing the screen or presenting the knowledge lamp to all of us. I'm thankful to the other members of the organizing team for organizing this inaugural session. And at the last, I'm thankful to the top management of ICMMIT University, Jharkhand, for allowing us to have this conference on a virtual platform. Thankful to media partner, thankful to media committee, and at the last, but not the least, I'm really grateful to our IT host from ICMMIT University headquarters. Thank you all, and may bless each one of us healthy life, free from corona here and after. Thank you.
Thank you, sir.
Thank you, sir. With that, we come to the end of this beautiful session, and we'll move ahead to 1.5 days of knowledge pack session. We'll take a short 15 minutes tea break. I request the presenters of the day to kindly log out of the Zoom session and join their respective tracks. There are 3 parallel tracks that will be going on. The schedule has already been shared with you all. Please select the correct link and join your respective room for presentations. That will start at 12 p.m. sharp. You are requested to join the room by 11:45 so that there is no glitch at the end. With that, thank you everyone present here. We'll again meet in the respective tracks. Thank you all.
Thank you, sir. Thank you.
Thank you all.
Thank you, sir. Thank you, ma'am.
And so now, with the due permission from our Honorable Vice Chancellor, sir, respected Director Sir, Register Sir, I request our IT host to kindly conclude this one, this session, inaugural session, so that you can go to the technical sessions.